Hello folks, my name is Ali and I've been curious to see how much using a new heat pump would be in Toronto comparing to a typical gas furnace in terms of operational costs. In this video I tried to crunch the numbers and answer this question. I have two systems here, a carrier furnace 59SC6A with 60,000 BTUH capacity on natural gas with 95% FU efficiency, meaning that 95% of the gas combustion energy heats up the house. And the other system here is a Carrier 25 VNA4 heat pump with 48,000 BTUH capacity on electricity. As the efficiency of the heat pump varies with the outdoor temperature, I've broken down the performance chart into three zones that made sense in terms of product performance and used the average numbers for the sake of this comparison. Okay, this is my sample case, including a pretty new typical two-story 1600 square feet semi-detached house not too far from Toronto's airport with about 50,000 BTUH heating load, and assuming four people in this house are comfortable with 70-degree Fahrenheit set temperature, and based on the building structure, let's assume that the heating system needs to kick off whenever the outside temperature is below 65 F. There are a few other assumptions here that you can see. I used a great concept here called HDD, and that's heating degree days, a measure of how much in degrees and for how long in days the outside air temperature was lower than the specific base temperature. They are used usually for calculations relating to the energy consumption required to heat buildings. The considered period of time is October 1st to September 30th, with a concentration on heating season starting on October 1st to April 30th. So the area below each of these graphs show the delta T to base temperature, like 65 or 77 or 37 or 17 multiplied by the period in days. This gives us what we need to factor in the efficiency change of heat pumps due to the lower outdoor temperature. Let's take a look at gas furnace equations. Heating load in a tight house is a function of the building structure and the infiltration air that are pretty constant for a given sample house. So the main variable here would be the temperature difference of outside air with our base temperature, which is 65 F. And this is where the HDD comes in. The calculated natural gas cost, as you can see, is a summation of all components including delivery, transportation, federal tax, gas supply charge, etc. And the electricity rate is a weighted average of the rates in Toronto. As you can see, the total cost for furnace in the heating season is about $1,200. And now heat pumps. The equations are a little bit more complicated, and what I showed here is just a quick summary. The operation days are broken into three ranges of median temperature, and for each day, the heat pump efficiency is calculated accordingly as the COP of HP or heat pump varies with outdoor temperature. Still using same HDD concept for heating load. Also, an electrical heater of 4 kW is needed as a supplemental heating source when the outdoor temperature falls below 17 F. This threshold can obviously change based on the appliance model and cold climate adjustments. But you can see here that the total cost is $867.3, and this is only for heating season of this heat pump. Okay, finally got a chance to compare the running costs of a new heat pump versus a new furnace. My calculations show that a single family home could save up to 40% on energy cost with a heat pump. Of course, there are other things to think about like the upfront cost, existing installation, local energy costs, and so forth. I benefited from a few simplifying assumptions here that might impact the overall result, but hopefully that is not too much. Okay, thank you very much. Let me know if you've had a similar experience and compared the savings between the two systems. And a quick disclaimer here, just to make sure that the purpose and scope of this video are clear. Thank you again.